Hi, everyone. We are now going into chapter 12, and 12 and 13 is all we have left in the course. Chapter 12 is the start of three-dimensional coordinate systems. So now we're going to be looking at an x-axis, a y-axis, and a z-axis, and then how does that apply when we do things with vectors or integrals, derivatives, and all that sort of stuff. That's where we're aiming, and this will actually carry on from this section all the way into Cal 4 if you're going to be taking Cal 4 this summer or this fall as well. So, when talking about a two-dimensional space, you need a point, an x and a y, and you end up on an xy plane. You divide the plane into four quadrants, quadrant 1, 2, 3, and 4. When you're talking about three dimensions, you have to have a left-right x coordinate, an up and down y coordinate, and then a z coordinate as well to come out of that flat plane. And that will give you a point in the xyz plane. But it's not really a plane, but that's just one of the words they use that kind of comes over from the two-dimensional thing. But this space, this 3D plane, if you will, is divided into octants instead of quadrants. So there are 8 different octants. So you have, for instance, the octant where all three numbers are positive, x, y, and z. Or maybe one of them is negative, or two of them is negative, or all three of them is negative. So all those different combinations come out with 8 different octants. And so this down here on the lower left is one way that we can draw our x, y, z plane. So x to the left, y to the right. That's the flat plane, and then you have the vertical z-axis coming out of it. And it's very much like if you were to look at a wall in a room. You have the xy plane as the flat bottom part. That would be the floor of your xy plane. Then you have the two walls. You have a xz plane, and you also have a yz plane. That would be the left and right wall. And so there are intersecting planes that are making these different octants pop up. So that's your three-dimensional coordinate system. Also, I do realize that a lot of this stuff in this chapter will be repeats of things that you'll see if you are taking, say, physics. We'll talk a lot about vectors and stuff in this chapter as well. Three-dimensional space is also talked about in physics. So if this is a lot of repeating, I apologize, but it is possible to take Cal 3 and never take an engineering or math or engineering or a physics class. So some people have not seen that. So if it is repeated, just go with it and enjoy this chapter. So suppose you start at the origin and you move along the x-axis a distance of 4 units in the positive direction, and then you move downward a distance of 3 units. What would actually be your positioning? Where would you end up at, basically? And so you could draw it out if you need to. You may not even need to draw it out. If I do, let's see, I'll probably draw it the same way. This will be your x. This will be your y. That's your xy plane. Your z would come out. Ooh, that was supposed to be a straight line. This is where I was saying in the other chapters, I'm not very good at drawing. And so this is supposed to be a straight line for z. And so if you're starting at the origin, and you move along the x-axis, 1, 2, 3, 4, and then you move downward a distance of 3. Now, downward would be the negative direction, so we might want to put a negative axis that way. And you move down a distance of 3, you're going down on the z-axis, so you would go 1, 2, 3. So that particular spot would actually be in the xz plane. You didn't go along the y-axis at all. This point right here is the point for 0, negative 3. 4 in the positive direction, down 3 would be negative, and you didn't go along the y at all. So that's not actually a bad graph for me anyway. You all might have a much better drawing ability, but that's not too bad for me. How about the distance formula? So the distance formula is the same as it is in the two-dimensional space as it is in the three-dimensional space. In two-dimensional space, you end up with x2 minus x1 squared plus y2 minus y1 squared. So just this part is the distance formula in 2D space. If you're doing 3D space, you have to add in the z component. This example says, which of these points is closest to the yz plane? And which is closest to the xz plane? Now, in this case, you don't really need the distance formula here to do this type problem. We'll get back to the distance formula a little bit, but you could find the distance between all of the points and see which one is the closest. But you can kind of cheat on this one. When it says which one is closest to the YZ plane, then you want to know which one has the closest. You're looking at the x value. Which x value is closest to 0? And so the one that's closest to 0, you have a -4, a 3, and a 2. This 2 is only 2 units away from 0. It's all based on that 2 right there. And so the one that's closest to the the YZ plane is the C point, the 2, the 4, and the 6. Or if we were looking at which one is closest to the XZ plane, you're going to look for the Y value. Which Y value is closest to being 0? Well, you have a Y value that actually is 0. That's in the point A. So our point A of -4, 0, -1 would be the closest to the XZ plane because it is literally in the XZ plane. Point B would be 1 unit away from the XZ plane, and point C would be 4 units away, looking at the Y value. So hopefully that makes sense. What does the equation y equals 3 and z equals 5 represent in R3? So in R3, that's your three-dimensional space. You might remember back in, say, algebra, if you had a y equals a number or an x equals a number, you got a vertical or a horizontal line. That does not happen in 3 space. And so the y equals 3 would be a plane. Well, actually, let me write that in green. And there's a reason for that. I'll show you in a minute. Would be a plane that cuts through the y-axis at 3. Whereas z equals 5 would be a plane that cuts through z equals 3. You put them together, and what you end up with is 2 planes that intersect. 2 intersecting planes is one definition of what a line is. And so we can illustrate that by a graph. So this is why I had to go back and do it in green, because the green vertical plane here, that's going through the y-axis at 3. So you might notice there's a intersecting point on the y-axis right here. And I said z equals 3, but it's supposed to be z equals 5, wasn't it? I'm sorry. The z equals 5 is a plane going through the z-axis. That would be right here. And notice the intersecting spot would be this black line right here. That's your line. That is your intersection between those 2 planes, and it makes a line. So hopefully that helps with the graph there. But Anytime you have y equals a number, x equals a number, z equals a number, you'll get a plane. You'll get a flat plane. And when they intersect, you'll get a line. Okay, this one says find the lengths of the sides of a triangle PQR and determine whether you have a right triangle or an isosceles triangle or a scalene triangle. Now, what you'll have to find is the distance between these points. You have to find what's the distance between P to Q, what's the distance from P to R, and what's the distance from Q to R. So we'll find each one of those. Let's just start with P to Q. So the distance for P to Q would be the square root of, you take x2 minus x1, and it won't matter if you do the 3 minus the 7 or the 7 minus the 3 because you're going to square it either way, but I'm going to do the 7 minus the 3. Then I'll do the 0 minus negative 2. And I'll do the 1 minus negative 3. So you do the second one minus the first one for the x, the y, and the z, all the way across. So I'll end up with 7 minus 3 is 4, so I'll get a 4 squared. I'll get a 2 squared, and I'll get a 1 minus negative 3 is 4 again, so I'll get a 4 squared. So that is 16 and 4 and 16. 16 doubled is 32, plus 4 makes 36. This has a distance of 6. Kind of ironic that it came out exactly to be 6. Okay, let's do P to R. So P to R means I'm going to do the R minus the P. So I'll have a 2 minus negative 2 squared, and a 1 minus negative 3 squared. 1 minus 3 is negative 2. So I'll have a negative 2 squared. 2 plus 2 is 4, so I get a 4 squared. And 1 minus negative 3 again is 4. So I get another 4 squared. I actually get the exact same thing I had above this. I'll have a 4, a 16, and a 16, which again is square root of 36, which is 6. And my other one, I have PQ, PR. I need to do QR. And QR would be 1 minus 7 squared. 2 minus 0 squared. And 1 minus 1. Ooh, that's kind of ironic. 1 minus 1 squared. So 1 minus 7 would be negative 6 squared. And a 2 squared. And a 0 squared. So I'll get 36 plus 4, which is square root of 40, which doesn't come out quite as nice as square root of 36. You can simplify it. It is 2 root 10 if you want to pull the 4 out to take the square root of 4. And so this right here says I have 2 sides that are the same and 1 side that is different. 2 sides that are the same and 1 that's different tells you that you have an isosceles triangle. So this is an isosceles. That's a hard word to spell. It's an isosceles triangle. Now, an isosceles triangle can also be a right triangle. For instance, your 45, 45, 90 triangle is a right triangle, which has sides of either root 2 over 2 or root 2. They have 2 sides that are the same. And so an isosceles triangle is also possible to be a right triangle. They don't always have to be. But we do need to check to see if it is. This one will not be a right triangle because if I do the two sides that are the same, those sides are less than the other side because I know square root of 36 is less than square root of 40. And so if it is a right triangle, your biggest side has to be the biggest side squared has to be the sum of the other side squared. So I'd have to check, is 6 squared plus 6 squared, is that equal to 2 root 10 squared? Well, 6 squared is 36, and 36. The 2 root 10 squared is the same thing as square root of 40 squared, which is 40. 36 plus 36 is not 40. So it is only isosceles. It is not a right triangle. But it could have been. Now, it could not be isosceles and scalene. Isosceles is looking at the sides. Scalene is also looking at the sides. Isosceles says two of the sides are the same. Scalene says all three of the sides are different. But a right triangle could be, since it's based on the angles, could be either isosceles or scalene. So you'll want to check that on either one of those. So let's do another one. And we'll do that same process again. If I find the angle for, oops, I meant to do a P there. We'll do the same thing, PQ, PR, and QR. So starting with PQ. That is 4 minus 2 squared, 1 minus negative 1 squared, and 1 minus 0 squared. So that'll be a 2 squared, a 2 squared, and a 1 squared. Oh, this will come out nice. A 2 squared is 4 plus 4 plus 1. That is the square root of 9, which is 3. So that's a pretty good one there to work with. Let's do PR. So PR would be 4 minus 2 again. It would be negative 5 minus 1. Oh, negative 5 minus negative 1, actually. And 4 minus 0. And so that would be 2 squared. Negative 5 minus negative 1 would be negative 5 plus 1, which is negative 4 squared. And I'll get a 4 squared. So that'll give me 4 plus 16 plus 16. This is just like the last one. That is 36, which is 6. And then we got to do QR. QR. And so QR would be 4 minus 4. I always like it when they subtract off. I'll have negative 5 minus 1 and 4 minus 1. I bet this one doesn't come out quite as nice. That'll be 0 squared, which is good. Negative 5 minus 1 would be negative 6 squared. And 4 minus 1 is 3, so that's 3 squared. So I'll get 36 and 9, which is the square root of 45, which, again, doesn't simplify extremely nicely, but it is 9 times 5, so I could write it as 3 root 5. Notice every one of the sides is different, and if they're all different, then it has to be scalene. So this is a scalene triangle. But I also want to check whether or not all the sides sum up. Now this one's pretty easy to notice. Look at this column right here. 9, 36, and 45. 9 plus 36 would be 45. So this column right here will tell you, without doing the Pythagorean theorem, that this is a right triangle. But if you don't notice that, if I did 3 squared plus 6 squared, does that equal 3 root 5 squared? And you could type it in the calculator if you wanted to. 3 squared is 9, 6 squared is 36, and 3 root 5 squared would be 45. So 9 plus 36 actually is 45, yes. So this is actually a right triangle as well. So on our labeling over here, you could either say it's a right scalene triangle, or you could say it's a scalene right triangle, whichever you want to do. But it is both scalene because all the sides are different, and it's right because the sides add up correctly using the Pythagorean theorem. So hopefully that's not too bad. Okay, let's find the distance from the point 4, negative 2, 6 to each one of these things. The xy plane, the yz plane, the xz plane, the x-axis, y-axis, and z-axis. You notice I don't put a whole lot of room on here. You don't need a whole lot of room to do most of these. For instance, to do the xy plane, this is kind of like one of those ones we did earlier. To do the xy plane, you're looking at the z coordinate. Look at the z. The z is 6, so this distance is 6. You are 6 away from the xy coordinate, or the xy plane. Or on the yz is missing the x. So I look at the x coordinate, my distance is 4. It is the absolute value of the whatever the point, the coordinate of the point is. If I look at the xz plane, I'm missing the y. So the y coordinate is negative 2, but distance is always positive. So my distance would be 2. So hopefully that's not too bad. Now as far as the x-axis, y-axis, and z-axis, you'll probably want to put a point in there to kind of see how this works. So let's go with red. So if I'm going to do the x-axis, for instance, what happens is the 4 needs to go away because I'm going to subtract that part off. So you could do your distance formula like what we were doing, and I'd have to use the point, the 4, negative 2, 6, like this. But to figure out the distance from the x-axis, I need to base that on the y and the z coordinate. So I'm going to subtract off the point 4, 0, 0 to get rid of the x coordinate. And so this distance, the 4 minus 4 is 0, so that one just goes away. And so I'll get negative 2 squared, which is 4, and 6 squared, which is 36. This is square root of 40, or 2 root 10. And that would be your distance. It's basically the distance formula in your 2D space. And you can see that a little more when we get down to the z-axis one. If I did the y-axis, I need to get rid of the y term. And so to get rid of the y term, I would still use the point 4, negative 2, and 6. But now I'm going to subtract off zeros on each one of those. But I got to get rid of the y here. So I'm really subtracting -2 off or adding 2, whichever one you want to do, to get rid of this term. And so my distance would be 4 squared, which is 16, and 6 squared, which is 36. Or that's the square root of 52, or 2 root 13 if you want to simplify that. For your z-axis, again, the first part is going to be the same. I have to have the point 4, -2, and 6. But I got to get rid of the z part. So I'm going to pick the point 0, 0, 6. That will get rid of this piece. And you actually have just the distance formula in the xy plane, because that's figuring out the distance to the z-axis, which is kind of weird if you did zeros in there. So you're doing the origin. Anyway, so this is the square root of 16 plus 4, which is the square root of 20, or 2 root 5. And that would be the distance to each one of those things. So hopefully that makes sense. Okay, let's talk about spheres for a minute. The equation of a sphere is the same basic outline as the equation of a circle. So if you're talking about a circle in 2 dimensions, your circle is just this first part equal to r squared. X minus h squared plus y minus k squared equals r squared. That's the equation of a circle. Now we're going to add in this z component here to make it be a sphere. And basically, if you're going to get a nice sphere, you're going to get circles around the x-axis or the y-axis or the z-axis. A circle itself in a 2D space is actually a circle going around the z-axis. So you can adjust that accordingly to get the sphere. Or if it's at the origin, you just have x squared plus y squared plus z squared equals r squared. So our first question says, find the equation of a sphere with a center of -3, 2, 5, and a radius of 4. Well, you just plug those numbers in. I'll have x plus 3. I'll have y minus 2 squared. And I'll have z minus 5 squared equals 4 squared, which is 16. And that would be the equation of my sphere with that center. And then it also says, what's the intersection of that sphere on the on the YZ plane? Since there is a YZ here, you're going to be really looking at what happens with the X values. And so if it intersects the sphere on the YZ plane, that means your X's had to be 0. And so all we do is we plug 0 in for the X and see what happens. So if X were 0, I would have 0 plus 3 squared plus y minus 2 squared plus z minus 5 squared equals 16. So this would be a 9 left over on this side. And if you subtract that 9 over, you'll get y minus 2 squared plus z minus 5 squared, and 16 minus 9 is 7. So this is your intersection. Your intersection is a circle centered at 2, 5. Well, actually, sorry, it's 3 coordinates. So 0, 2, 5. Well, no, it's just a circle. Never mind. I'm thinking that wrong. At 2, 5 in the YZ plane. With radius square root of 7. So your intersection is a circle. because it runs into an entire plane. Isn't that odd? I've always thought that was odd. Okay, let's do another type of sphere problem here. Find the equation of a sphere that passes through the point 4, 3, negative 1, and has a center of 3, 8, 1. So if it passes through that point and has the center, then the radius would be the distance between those 2 points. So let's just find the distance between those 2 points. So your distance would be the square root of, that was supposed to be a straight line again, but it's okay. I'm just going to do the 3 minus the 4 squared, subtract the x's, subtract the y's, 8 minus 3 squared, and 1 minus negative 1 squared. So 3 minus 4 is negative 1 squared is 1. 8 minus 5 is 8 minus 3 is 5 squared is 25. And 1 plus 1 is 2 squared is 4. So this is the square root of 30. This has to be the radius of my sphere. And then since I have the center, I can just pretty much write down the answer. I'll have x minus 3 squared. I'll have y minus 8 squared. And I'll have z minus 1 squared equals r squared. Well, the square root of 30 squared is 30. And there is my equation of my sphere through that point with that center. So hopefully that's not too bad. That's a fairly easy one, I think. Okay, let's try this one. This is kind of going the other way around. Here's an equation that is a sphere. You find the radius in the center. And this has a lot to do with algebra back in the day when you would do something called completing the square. And so I want to rearrange these terms to get all the x's together, all of the y's together, and all of the z's together. So I'm going to do an x squared, a minus 2x, and a blank. And then I'm going to do the y squared, a minus 4y, and a blank. And then I'm going to do the z squared, the 8z, and a blank equals 15. And I put 3 blanks on the left-hand side, so I'm going to put 3 blanks on the right-hand side. And those blanks will be filled in by what you get when you complete the square. And so to complete the square, you take the number in front of the linear term. So like the z squared plus 8z, I would take the 8 in front of the z, take half of it and square it. Half of 8 is 4, squared is 16. So that's what goes in this blank. And I'm going to put that on both sides. Looking at the 4 right here, I take half of 4, which is 2, squared is 4. So I'm going to put a 4 right here and a 4 right there. Half of 2 is 1, squared is 1. So I'm going to put a 1 on each side. And what that does is now my first 3 terms factor, my second 3 terms factor, and my third 3 terms factor. So this first part, x squared minus 2x plus 1, that is x minus 1 squared. Y squared minus 4y plus 4 is y minus 2 squared. And z squared plus 8z plus 16 is z plus 4 squared. The right-hand side, you just have to add all the numbers up. 15 and 1 is 16, and 16 is 32, and 4 more make 36. And now I have it in my standard form of an equation where my center is the point 1, 2, negative 4, and my radius is the square root of 36, which is 6. And that's my answer. So hopefully that's not too bad. Okay, let's try this one. This one's a little bit more complicated. Again, I want to kind of gather all the terms together and leave those blanks along the way. But to do completing the square, you got to have the x squared and the y squared and the z squared have a coefficient of 1 for this to work out. So that since it says 2x squared, 2y squared, 2z squared, I really need to divide everything in that problem by 2. But I'm going to do that after I move the x's and the y's and the z's. I only don't have any y's, but the x's and the z's to the other side. So I'm going to write this as 2x squared. Then I'm going to subtract that 8x to the other side and leave a blank. And then I'll have a 2y squared. And that's it. With no y terms, you don't need a blank there. And so we'll just jump to the z's, 2z squared, add the 24z to the other side, and leave a blank. And I'll have a 1 plus a blank and a blank. I only have 2 blanks here. But like I said, before we get going, I'm going to cut everything down by a half and make this be x squared. Yep, it's not a plus, it's actually a minus. So everything in the problem getting cut in half. Minus 4x. Now I'm not going to cut a blank in half, so it's just going to stay a blank. And then I'll have a y squared and a z squared and a 12z and a blank, and that includes the 1 on the other side. I'm going to have a 1/2 over here. Then I'm going to go through that same process that I did on the last one for this one. The 12 right here, I'm going to take half of that number and square it. I'm going to say 12 divided by 2, which is 6, squared is 36. So I'll have a 36 right here and a 36 on this side. For the 4, I'm going to take half of 4 and square it. Half of 4 is 2, 2 squared is 4. So I'll put a 4 on both sides. So the first 3 terms factor. This is x minus 2 squared. The y squared doesn't need to factor because we're not adding anything into it, so we're going to leave that the way it is. And then we'll have a z, 2 numbers multiplied by 36 would be 6, so z plus 6 squared. The right-hand side, you get 40.5. So 36 and 4 make 40, which is 80 halves, and 1/2 make 81 halves. And so there's my standard form. This has a center of 2, 0, negative 6. And the radius, with radius, you take the square root of the number on the right. The square root of 81 would be 9, and the square root of 2 is square root of 2. You can rationalize it if you want to, or you could leave it just like that. I don't really care one way or the other. Okay, just for fun, we'll do one more of those. Same idea. Here we have 3's in front of everything, so I'm going to have to get rid of those 3's along the way. But I'm going to kind of rearrange stuff here. There's a 3x squared. There is no x term by itself, so we'll just skip that and go to the 3y squared. There's a plus 6y, but I got to move it to the other side, so I'll do a minus 6y and a blank. And then a 3z squared. Move the 12z to the left-hand side and put a blank. And leave the 10 with 2 additional blanks. Because there are 3's in front of the squared terms, I got to cut everything down by 3. So this will turn into an x squared, a y squared, a 2y, and a blank, a z squared. Cutting it down by 3 will give me a 4z. And this would be cutting 10 down by 3 gives me 10/3, which that doesn't look very nice, but oh well. And so we'll do that same process again. Completing the square, I take the 4 and take half of it. That's 2. Then I square it. That gives me 4. Or I'll take the 2 on the 2y, take half of it, and square it. Half of 2 is 1, squared is 1. And so the x squared doesn't have anything to work with, so that's just going to stay a center of 0 for that one. The y's will become y minus 1 squared, if you factor the y squared minus 2y plus 1. And the z's will become z minus 2 squared. The right-hand side is 4 plus 1 is 5, which is 15 thirds, plus 10 thirds is 25 thirds. So I end up with a center of 0, 1, 2. I bet I did that on purpose. 0, 1, 2. With a radius the square root of 25 would be 5, and the square root of 3 is square root of 3. And that would be my center and my radius of the sphere. So hopefully you're an expert at completing a square at this point. Okay, this one says find the equation of a sphere if one of its diameters has endpoints of 5, 4, 3, and 1, 6, negative 9. So the diameter goes from side to side of the sphere. Right in the middle would be the radius. And I can find that by using, back from algebra, the midpoint formula. So I need to find the midpoint, which in our case would be, not the radius, the midpoint would be the center. And to find the midpoint, I just take the x's, add them, and cut them in half. Take the y's, add them, cut them in half. Take the z's, add them, cut them in half. And so that would be 6 halves, 10 halves, and negative 6 halves, which would be 3, 5, negative 3. This is the center. Then I need the radius. To find the radius, you have a couple options. You could take the original 2 points they gave you, find the distance across it, and cut it in half. That would be the radius. Since it's a diameter, cutting the diameter in half gives you the radius. Or you could use the center you found in one of those points to come up with the radius, either one. I'm going to use the center. So I'm going to use this first point and that center right there and come up with the radius, which would be the distance between those points. So I'm going to do the 5 minus the 3, the 4 minus the 5, and the 3 minus the negative 3. And so I'll get 2 squared, which is 4. I'll get negative 1 squared, which is 1. And I'll get 3 and 3 make 6 squared, which is 36. So I'll get 36, 40, 41, I believe, if I did that right in my head. And so there's my radius, there's my center, so I can write down the equation of my circle, or my sphere, would be x minus 3 from the center, y minus 5 from the center, and z plus 3 from the center. And you do the radius squared, which would just be 41 without the square root on it. And there's the equation of my sphere. So hopefully that's good too. Okay, find the equation of a sphere with the center 2, negative 3, 6 that touches the xy plane. And I kind of mentioned this a little bit earlier, but if it touches the xy plane, notice there's no z there. So if it touches the xy plane, that means your z has to go away. Oh, sorry, no, ignore that. I'm thinking something else. If it touches the, I'm thinking intersection, so ignore that what I just said. If it touches it, what you want is the radius to have the end of the sphere touching the plane. And so in that case, we're still basing it off the z, the missing term. So since your z is missing, I want to use my z value to be my radius. So my z is going to be my radius. And so I'm going to have x minus 2 squared, y plus 3 squared, and z minus 6 squared. And 6, the z value squared, is 36. And so that would be the sphere that touches the z-axis. Or if you're doing the yz plane, I let x be the radius. And so I'll have, the first part is going to be the same on all of them. The center is not changing. So x minus 2 squared, y plus 3 squared, z minus 6 squared. But now I'll have it be equal to 4. That would be my x value. Or on the last one, you might notice there's no y. So my y would be the radius. And so again, first part not changing at all. We're writing the exact same thing down again. Except now the y value is -3. -3 squared is 9. And that's the equation of the sphere that touches the plane, not intersects like I was going to do in my head, the first part of it. So this is just touching the plane. So that's not too bad, hopefully. And one last problem, find the equation of the largest sphere with that center of 5, 4, 9 that is contained in the first octant. So you want the biggest sphere you possibly could have that is in the first octant. So the sphere must have a radius equal to the minimum distance, because anything bigger than that smallest number that would make that distance would push it over into one of the other octants, maybe the second octant, third octant, whatever. And so what we do is we pick a radius based on the smallest number, the shortest distance. And so the shortest distance would be based on the 4. Because once you get more than 4 units away on the y-axis, you're going to bump over into a different octant. So I got to base the radius on the 4. So the equation of my sphere would be x minus 5 squared, y minus 4 squared, and z minus 9 squared. Using the smallest number, the 4 squared is 16. And that is the equation of the sphere that I know would be locked into the first octant. Anything bigger than 4, since it's a y value, would hit the xz plane. And so we can't go further than that plane. And that's why I would pick the 4. So hopefully that's pretty good. That is all of 12.1. And so especially if you've seen some of this stuff before, you'll definitely probably have seen the rest of this first 3 or 4 sections. We're going to do a lot of things with vectors coming up.